GWalkR is a new R package that was launched this year, and it claims to be able to turn your data frame into a Tableau-style drag and drop UI interface to build visualizations in R. And it was created by the Canaries, Canaries is a open source startup that deals with mostly data exploration and data visualizations. So we can see this is their GitHub tutorial about what is GWalkR and how do we get started using GWalkR. If you're using Python, you can check out gwalker, as they call it, which is an alternative of this package in Python that does the same things in Python. So this is the setup instructions. As you can see, they're very simple. And what's fascinating about this is that it only uses one line of code. Once you read in your data, you just need to call this GWalkR function and then just put your data as an option, as an argument, and then you have your visualization. It does everything in the back end. It's already programmed to call other functions that you can that are needed to to do the plotting. As you can see here, this is a demo by the creators of this package, where they show you how it is in action. Just basically, click and drag and drop. That's it. Other cool things that you can do is, like when you're visualizing, is to you can brush over the specific points of interest. Like you can see they're brushing some points orange, just to highlight them. And yeah, it's a very cool package, and you can check it out on GitHub, Canaries GWalkR, or also on CRAN. It's already available on CRAN. It has the reference manual. This version was published in April. So yeah, so I'm gonna just show a demonstration of this package using a different data set, which is a data set of maternal death review in Kenya. And so we're just going to see where the maternal deaths occur by location, and try to see like which are the locations with the highest maternal deaths and other characteristics of those deaths. So let's get into it. Yeah, so this is RStudio. As you can see, you just need to install and load the packages that you need. So we will use GWalkR, Shiny, and Read Excel. So let me just run that, and this will check if the packages are already installed, and if not, it will install them. And since they're already installed, then it just confirms that they've been loaded, so we have them readily available. So you just need to read in your data, and then yeah, to give, says there are some warnings. I think it's to do with maybe some values that it was expecting to see but did not see, because I think of how the variables have been formatted, but I don't think that will affect our analysis. We can confirm that it has all the variables and the rows, all the columns and the rows. It's a small data set, 2,586 rows, 116 variables, and we subset those variables just to get the variables we are interested in, which are county, the level of the facility, the age, the education level, and so on. And we get a subset of the data with only those variables, and we confirm that it has selected the 9 variables that we're interested in. This is the interesting part. You just need to type GWalkR and your dataset, and that's it. So let's run that and see what comes up. And here you have your screen with your visualization, and right, you can see it's basically everything is there. All the variables are here on the left panel. You have your county, your level, education, and these are the categorical variables. The numeric variables are here with the hash symbol, age, row count, and measure values. So let's see, we can start with maybe the county and see, okay, the county, we can put it in the x-axis, and then we see the count, like how many records are there, or how many deaths are there in each county. You can put this on the y-axis and it will demonstrate. Like you see, it's a simple bar plot. It's the default in this package. There are different options. If you click on this button, the orange button, you can choose a bar plot, a line plot, area plot, trail, scatter plot, circle, different types of plots, box plots. You can even just choose a table. But let's just look at the bar plot for now. And if you want to maybe look at another dimension or characteristic, for example, education level, maybe you want to see how what the education levels of the women who died were in each county. You can take your education level factor and drop it here in the color, and there you go. It gives you, like different colors for different education levels. I don't know if there's a way to make this bigger so that you can see the legend where it shows the what the different colors represent. But I can see that when you hover your cursor around on the bar, it shows you, it gives you a box to show you this is the blue is primary school, the orange is secondary school, and it gives you the count, like 58 that were in secondary school, 71 in primary school, and so on. So it shows you most of these counties, the women were in primary or secondary school. Very few were in tertiary, which is in the red color. As you can see, 29 in Kisumu, 23 in Bungoma, 39 in Nairobi County. Only very few were in tertiary school or tertiary educational level, which is college, anything above secondary school. So that's an interesting insight. Also, there are a lot of unknowns, like in Garissa, most of the women does not know what their educational level was, which, someone might be curious as to why this is not known. Is it because of, maybe this information was not recorded for some reason, or the women are not forthcoming with that information? So it would be curious for anyone planning an intervention involving that county to explore further why the differences. I mean, in all the counties, you can see there's a lot of variation. But the kind of the pattern is clear that most of the women were of, a basic education level, which is primary and secondary. Yeah, so it's a very interesting kind of visualization, very simple, where you can just, drag and drop whatever variable you're interested in, and it will give you the visualization immediately. As you can see, we didn't type any other line of code. We just the original GWalkR, and everything is here. We just need to move variables around on the different settings, and it will give you different results. So another key feature is you can export this plot. See this button, just click it. You can export as PNG, you can export as SVG, you can export as base 64. I don't know what base 64 is, but I think PNGs and SVG I'm more familiar with. So you can feel free to explore any of those. I have tried exporting before, and it goes directly into your downloads folder in C. So it will just ask you to put the file name, and you'll find the file in your downloads folder in C. So let's look at another variable, maybe place of delivery. Maybe where were these women, in what kind of facilities did they deliver? These women who died of maternal deaths, maternal causes. So this shows you again the same counties, but you can see now we're looking at a different dimension, which is where the deliveries occurred. So here you can see most of them. The red was in a level 3 facility, and the greenish bluish was in a level 4 facility, and the green light or jungle green is kind of a level 5. It's a level 5 facility, and the yellow is a level 6 facility. So again, you see most these counties with high numbers of deaths, most of them occurred in level 3, level 4, and level 5, and level 6. Very few occurred at, let's say, level 2 and below. So level 3 is the health centers, level 4 is the county hospitals, level 5 is the county referral hospital, and level 6 is the national referral hospital. So all of these levels from 3 to 6 are expected to have the required facilities, equipment, staff that can handle maternal deliveries. So you'll find they have, the maternity ward. They have the doctors who can be able, and the midwives who can be able to manage pregnancy cases. So that's interesting to see that, again, that's where most of the deaths occur. And so maybe we can look at another factor. For example, what category of death, or what classification of death did these women have? And this is based on the WHO ICD 11 maternal mortality classification. So we can see this is Nakuru. Nairobi has the highest number of deaths, followed by, I think, Nakuru, and then Kisumu, and then Kakamega, and then Bungoma. So here we have Nairobi. Most of the deaths were due to obstetric hemorrhage and hypertensive disorders. Same thing as Nakuru, hypertensive disorders including eclampsia and preeclampsia. So you can see again the same story. Obstetric hemorrhage is the highest cause of death, maternal death. Mombasa, same thing, hypertensive disorders and obstetric hemorrhage. Kisumu, same thing. Kakamega, the same story. And all through the other top counties with the highest numbers of maternal deaths. Can see also the brown is unknown. Still a lot of cases where the cause of death was unknown. It was not provided, or maybe there are a lot of reasons why maybe the cause of death was unknown, was not able to be diagnosed, or was not written during the maternal death review. So that's another thing, because it's a very big number of women whose cause of death is not known. Just that it's known it happened either during pregnancy or during childbirth or in the 42 days after pregnancy. So this is another key finding and very interesting insight to probably look into whether there are challenges in understanding even how to code the causes of death based on the ICD-11 or whatever classification that is used by the Ministry of Health. Another thing we can look at is maybe we can remove county and look at the year and see, for example, by year, which was the top cause of death by year. And this data has all the maternal deaths that were audited in Kenya between 2014 and 2020. And let's see if we can change the type of graph to something else, maybe to an area graph. And then we can see it's a bit small. I think you can tweak this panel on the right, the plotting panel, maybe to make it a bit bigger, because it's looking very small. I'm sure there's a way you can probably tweak it. So you can see this kind of bluish green color is obstetric hemorrhage. It's increasing each year. You can see the number of women with obstetric hemorrhage was very high in 2020 compared to 2014. And the same thing, to a lesser degree, is the hypertensive disorder. And this one in green is other obstetric complications. And the one in purple is pregnancy-related infection, including sepsis and others. And this is another big, number of unknowns. You can see how the unknowns are so many compared to, some of the other classifications where there are very few women. So this is also curious, it's a curious finding why, every year there's a large number of unknown cases where, of course, it's reducing. In 2014, it was almost 50% of women had their cause of death was unknown. But you can see in 2020, compared to all the others, it's a very small number that had an unknown or undetermined cause of death. So that's a really good way to kind of quickly get, into your data and explore it, and you don't have to take hours or such a long time trying to figure out, trying to do different visualizations. If you're pressed for time, this is a very simple, very straightforward way of visualizing your data and exploring your data. So maybe now we can check, maybe we can remove the year of death and remove that and see if we can switch them around. maybe we put can go back to the bar plot. I've put the cause of death in the x-axis and the count, the number of women per cause of death. So you can see obstetric hemorrhage had the highest number of deaths. Still the unknowns were very many, very many, when you aggregate them across all the 7 years. And hypertensive disorders, the second highest cause of death. Pregnancy-related infection, number 3. And let's see, for example, if we check what was the mode of delivery for this women. Maybe we can put it here as the color and see how these women were delivered or delivered their babies. So we can see cesarean section in the red. A large number of women, had delivered via cesarean section, and the green was spontaneous vaginal delivery, which is the normal delivery by a skilled birth attendant. Also, a lot of these women delivered either normally or by cesarean section. And the yellow is normal delivery by an unskilled birth attendant. That could be a traditional birth attendant, could be anyone who's not skilled or formally trained in delivering women. For example, a nurse or a midwife or a gynecologist, and so on. So you can see again, still a lot of unknowns. It's unknown what mode of delivery, which would be strange. Maybe these ones were referrals, or maybe whoever delivered them was not around. I don't know if they recorded that information in the maternity register. Also, a number of babies that were breech, where the women died of obstetric hemorrhage. So it's very interesting insights that you can get from this. And another thing that you can look at is probably want to know which level of facility these deaths occurred in. So you can remove this maybe and put level in the x-axis and see by mode of delivery which level of facility, which was the most common mode of delivery by each level of facility. So we see cesarean section and normal delivery is mostly done in the most common modes of delivery in level 4 and level 5 hospitals or health facilities. Level 4 had the most number of maternal deaths. Level 4 is the county hospitals, which were formerly the district hospitals. Level 5 is the county referral hospitals, which are formerly provincial hospitals. And the others, small numbers of deaths. So if someone was interested in trying to address these high numbers of maternal deaths, probably the first place to go to would be a level 4 hospital. Try to understand why these level 4 hospitals, which should have all the facilities and equipment and supplies, are not able to manage, to reduce the numbers of maternal deaths. Similar with level 5 hospitals. Level 6, I think there are fewer national referral hospitals across the country. Would expect level 4 to be at least one level 4 hospital in every county. And so I think by the time women are referred, let's say from county to national, it's, or very few women are referred from county to national, where national would have much better quality facilities, higher numbers of staff, and it seems a lot of women prefer to deliver at county hospitals. So if there were interventions addressing reduction of maternal deaths, then probably the target facilities will be level 4 and level 5 facilities, to try and reduce the numbers of deaths there. So another thing that we might want to look at would be who or which health workers were responsible for these deliveries. So for example, we can put mode of delivery in the x-axis, and we can put we can color it by the person or the cadre of staff that conducted the delivery. You can put it in the color. Of course, cesarean section had the highest number of deaths, and normal births also had the second highest number of deaths. Unknown actually was a lot of women, a lot of unknowns where it's not known what mode of delivery that woman gave, how their babies were born. So we can see for cesarean section, most of them were done by obstetrician gynecologists. Yeah, and for normal deliveries, most of them were done by nurse or midwife. Yeah, and for the normal delivery by unskilled birth attendant, most of them were done by a TBA, that's a traditional birth attendant, or a relative, and the rest were unknown. For the breech babies, most of them were delivered by a nurse or midwife. So if we wanted to probably look at interventions that address, capacity building, capacity strengthening, motivation, health worker motivation, morale and motivation, we can look at OBGYNs, nurse midwives, and we can see, like cesarean section, we expect OBGYNs to be the most highly skilled in conducting them, but still there are a lot of deaths that occur. Was it because of the quality of care, because of the skills of the doctors, or because of they lack supplies, or like blood products, or maybe the woman arrived when it was too late, it was an emergency cesarean section rather than elective. So a lot of questions that can be asked about, why these women who died, they were delivered by skilled birth attendants, by nurses, midwives, obstetricians, gynecologists, but there's still high numbers of deaths, even by skilled health workers who are skilled. So that's a good point to highlight. I mean, you can see within a few minutes we've explored all of our 9 variables, and I can just show you how that looks like in terms of when you export these pictures or these plots, because you can export them as PNG or PDF or SVG, sorry. So this is how it looks like. I exported it as PNG and then converted it into a PDF. So you can see the first plot. You have all your counties. There are 47 counties in Kenya, and this category of unknown unknown is maybe the county name was not provided in the maternal death review form. So you can see by education level. Of course, you can rename your variables, so that it looks better according to how you want it to appear in your plot. You have by place of delivery, and you can already put those plots in your report. If you need to communicate the results to stakeholders, Ministry of Health, or other researchers, just quickly within a few minutes you have your plots. You can quickly compile them into a report, and it will be very interesting as an initial step as you also prepare to dive deeper into the data and analyze other research questions of interest, maybe looking at just going by the initial review or exploration of the data. You can see, and I'm sure you can tweak, even the display, the other dimensions of the plots to make it look better or bigger, or however you want it to be. Mode of delivery, in the classification of death, the cause of death, and the mode of delivery by hospital level, and who conducted the delivery by the mode of delivery. So it's quite interesting. You have all your plots there, and immediately you don't have to waste a lot of time. I'm sure GGplot is much more flexible and gives you a lot more power to make the plots customized, and you can do a lot more with it. And I think this one is just, this GWalkR package is just for you if you don't have maybe a lot of time to code the plots in GGplot, and you just want a quick analysis, exploratory analysis of your data. This is a good start, and you can try that out. So I'm just going to show you a different way you can visualize your data using maps. And we have this GWalkR with Shiny. You can actually use GWalkR with a Shiny app. You can make a Shiny app and call GWalkR in, and it will give you to bring up the app, and you can do the same thing that we did here, but in a Shiny app. So let's see how that looks like. So this code will just create the app, and then we will run it. So let's run this to create the app, and then we run that to show the app. This is a different so this will be using a different data set in this particular demonstration. We'll be using a data set that has all the maternal deaths and all the maternal deliveries in Kenya in 2020. This is different from the previous one because these maternal deaths are not reviewed. They're not reviewed at all, so it's just aggregate numbers of all the deaths that occurred in facilities in Kenya. So here we are looking at the facility and the latitude and the longitude and the facility maternal mortality ratio. So if you want to do like a map, you just click on this icon. You can choose generic or geographic. So we choose geographic. It shows you the map, and you can put your coordinates here. Have longitude, you have latitude. So the data set already has those coordinates. So which corresponds to lat and long. So we're going to just match it to the corresponding setting here, and immediately you'll see it knows where those coordinates are, They're in Kenya. You can see all the points, all the facilities in Kenya that had maternal deaths in 2020, scattered all over, but mostly in the west, in Nairobi and at the coast region, right? So what we can do is look at FMMR, and we can disable this feature which is called aggregation, which it aggregates the values that you put in. So if you have, for example, the number of deaths, it will aggregate them. But we don't need that right now. We just want to look at the FMMR. So we deselect that. We put FMMR as opacity so that we see where the counties were, or the facilities were, which had the highest FMMR. As you can see, it's Nairobi, around Nairobi. Yeah, it's very high. One was 50,000. And so, again, also in the northeastern. So it says sum FMMR, but we have disabled the aggregation, so it's not really doing a sum. It's just looking at the exact number that is in the FMMR column in your dataset. And so another thing we can do is maybe see the size, make the small bubbles, bigger or smaller depending on the magnitude of FMMR. So we can put FMMR here in the size, and it shows you, where, gives you like a better indication of which are the hotspots where there's a high facility maternal mortality ratio in Kenya in 2020. You can do this for different years just to compare whether there are some regions which have high maternal mortality compared to other regions, whether the hotspot regions are improving over time, and so on. So you can see this is quite high in the northeastern region. Again, in Nairobi, in Kajiado region, a bit less in the western part of Kenya. So mostly in the city, Nairobi, capital city. Of course, there's a high population of people in Nairobi, and it's expected that probably more deaths will occur where there's a high population of people. But in the northeastern, the population is very scarce, sparse. So you cannot. It's kind of strange that there's a high level of maternal mortality in the northeastern region. But we also know that they are under-resourced, highly under-resourced, and they struggle with basic amenities and facilities. And so that might be a reason why there's also a high number of maternal deaths in that region. And that's it. This is I think this is using leaflet. Yeah, it's using leaflet package to produce these maps. I'm sure you can do it for any other country if you have the coordinates. And this is a great way to visualize your data, using GWalkR, using Shiny. It's a very good app. I encourage you to try it. And just go to their GitHub page or to CRAN, or just install it directly in your R version, RStudio. Install GWalkR lib and then call it, and then GWalkR your data set. That's it. Very simple. And thank you to Canaries for making this very wonderful package. and I hope you have fun exploring it. All right, thank you.